So in this series of videos, we're going to take a look at the half-angle identities. And you can see here that I have the identities listed. There's an identity for the cosine, for sine, and tangent. Notice that when you look at the formulas for tangent, there's three different choices that I have to apply the half-angle identities. Two of those choices do not include a square root symbol, so maybe that's a choice you want to choose. Understand that if I do use a formula with the square root symbol, because when I take the square root of a number I get both positive and negative values back, then we choose the sign, which sign do I use, based on what quadrant my half angle falls in. So ultimately the quadrant of my angle, or the quadrant of my half angle, will determine the sign of my function. So let's look at an example where we're going to apply these. And in this first example, we're going to use the half angle identity to find the exact value for the sine of 22.5. Now, I haven't memorized, or I don't recognize 22.5 as an angle on the unit circle that I've been memorizing. So that's what these identities are there to address. So the way that I look at this is, if I have an angle here, which we're going to call our half angle, and if that is equal to 22.5, so in other words, if my angle is divided by 2 to give me 22.5, if I were to multiply the angle by 2, I would end up with 45. I do recognize 45 as a common angle that I can take sine, cosine, and tangent of, and that's the angle that we use in the identity. So the half angle formula for sine says if I'm taking the sine of my half angle 22.5, the formula looks like 1 minus the cosine of the angle A divided by 2. 1 minus cosine A divided by 2. Simplifying underneath there, I say 1 minus. Now the cosine of 45 is going to be the square root of 2 over 2. All of that's still divided by 2 in the denominator under this large radical. From here, I want to try and simplify this by getting rid of these complex fractions. So I want to try and multiply through by one number that would get rid of it. Since this denominator up here is a 2, and this denominator down here is also a 2, then I can multiply the top and the bottom by a single number, by 2 over 2, to get rid of those fractions. So just using the distributive property, when I take 2 and multiply it inside of here, I get 2 minus, and then this 2 times that fraction gets rid of the denominator, leaving me with just square root of 2. All of that's over 2 times 2, which is 4, and again under a single radical that looks like this. Now when I simplify this particular statement here, I could rewrite this, and maybe it's a little bit clearer if I do, by separating the numerator into its own under the radical, which would be 2 minus the square root of 2, still under this radical. And in the denominator, I can look at this as the square root of 4. So maybe you don't do this step, but technically what we're doing is, if we have a fraction under a single radical, I can rewrite it as the numerator under that radical divided by the denominator under that radical, and approach it like that. So this looks like the numerator has to stay. I can't do anything with it. It just becomes some kind of strange looking radical statement like that. But the denominator, when I take the square root of 4, just becomes 2. Now, because we need to know whether to make this a positive or a negative, I'm going to go back and I'm going to say, well, when I take the sine of 22.5, this is in the first quadrant, and sine is positive in the first quadrant, so the final answer here would be positive as well. And that's the answer that I'm going to leave it as, just like that. Let's try one more. This time we're going to look at the tangent of 75. Okay, the tangent of 75. So again, 75 is not a common angle that I know. So I look at this and say, well, if my angle divided by 2 is 75, then the angle times 2 would be 150. Now I do know 150. 150 is a common angle on the unit circle that I've been memorizing up until this point. So it's 150 that I'm going to use for my formula. So I have three choices for the half angle identity on tangent. I'm going to choose one of the two that does not contain the radical, just because if I can avoid those, I typically do. So I'm going to choose the one that says the sine of A, which is 150, divided by 1 plus the cosine of A. And this is the formula that I'm going to use because I had two more choices for tangent. Now the sine of 150 is 1/2, and 1 plus the cosine of 150 then would be negative square root of 3 over 2. So this is what I would replace the sine and cosine of to get something that looks like this. Now again, I have these complex fractions and I want to get rid of them. So if I look in the numerator, this denominator is 2 and this denominator is a 2. So I can multiply the top and bottom by 2 to get rid of my fractions in each of those positions. So the numerator becomes 2 times 1/2, which is just 1. And the denominator, when I multiply this 2 down here, would be 2 minus, because this 2 is going to cancel with that 2, 2 minus the square root of 3. So far, this is what I have. Now, if I didn't want to leave it like this and I didn't want this radical in the denominator, then what I would need to do at this point is multiply by the conjugate. Remember, the conjugate would be 2 plus the square root of 3. Multiply top and bottom by that, and we will eliminate the radical in the denominator. So the numerator just becomes 2 plus the square root of 3. And the denominator, when I multiply these two, when I FOIL these two together, I get the first term squared minus the square of that term, which would be 3. And 4 minus 3 is just 1, so this becomes 2 plus the square root of 3.